Okay, hello everyone. I think we're going to start. I'm not going to do any introductions, so let's just start. I mean, the Modna Casta is just a simple e-commerce shop. I mean, you just write some code, it makes some orders and all the stuff, right? Everybody can do that. There is some load, like 1,000 RPS on a normal day during, I don't know, low season. But we have some events where it grows. And it all actually starts for me in 2015 when I joined the company in January. And it was almost, I mean, it says 80,000 plus, but I'm not really sure how many lines were there. Around 100,000 or something like that. And when it's written in Python, it becomes a bit unmanageable, right? Because it's a dynamic language, it's all intertwined, and you fix how your products are displayed, and suddenly your order stopped, well, ordering, I don't know. And so there were a lot of issues, support requests. We had around 200, 300 mails coming to a support email every day from our call center. It was just really hard to maintain. And I actually came after they made a Black Friday event when it was a huge commercial success. And they were dead for 4 hours in the end of the day when the most interesting part of the day. And I'm going to tell you a bit about why it died on the Black Friday. I'm not going to tell you all the details because it died because of various stuff, like a lot of things were wrong, but I'm just going to tell them my favorite story about metadata pairs. It's a beautiful name for a beautiful thing, and that's an actually pretty okay design for key value storage, right? You have those keys and values. They are called metadata value. Well, actually, that's Django, so it's called product metadata value, right? Because Django prepends an application name to everything, so it's a bit nicer. But anyway, you have those keys in different tables so that they are not repeated. I mean, a way to conserve some space on disk, maybe, or something like that. Anyway, so it was like that. But let's just look what the data is there. And if we select all the counts, we have key. It's actually only 6 keys. And the one key says volume in Russian, which is really nice because you always store things in database in Russian. That is like an anti-pattern. And then, I mean, there is an empty string here. It's not a space, I checked, it's just empty string. And then there is a description, like number, and 2 sizes. But the difference, it's written here, the difference is that this R is actually P. It's called Pazmir. It's just, you know, somebody made a mistake, so it's weird like that. And you can see that almost everything is actually size. So what they did, they reused this table as, you know, when you open a product page, there are sizes which you can buy. And those sizes should have IDs. And those IDs were actually those IDs of metadata pairs. So instead of using metadata pair as key value storage, they use it as a storage for sizes. But it doesn't stop here. I mean, every size has a stock, like 5 M of this t-shirt, right? And a stock is a table with 2 fields, stock count and sold count, but it has no relation to metadata pair. It has metadata pair, sorry. I mean, I've said it millions of times, so it's a bit weird to pronounce it in English. So you have this table, which is many-to-many table between stock and metadata pair, and it's called product metadata pair, stock metadata pairs. And it becomes a little bit better because there is a basket, and basket has a basket item which is related to product, but then there is basket item metadata pairs, which is, you know, many-to-many between those. I mean, can there be few sizes in a single basket item? Well, there can be, but I mean, maybe someday. I don't know what we're thinking when doing that. But anyway, the biggest problem was that you made 22 queries to a database to get a single size. I mean, it's Django RM, so it's written somehow, and it somehow works. Nobody cares. So for 5 sizes, it's 110 requests. on a page. And you open a page with 5 sizes and issues 110 queries to a database. But I mean, let's just fix it with cache, right? It's just like apply some cache. But the thing is, if the user opens a page and sees all those sizes, and there is a single t-shirt of size S, and that t-shirt was added to this user's basket, you want to show this size as available, because it's available for him. So let's cache depending on the user. I mean, every new user opens, and it makes 110 requests to a database. And yeah, so I mean, it took me actually 4 months to understand what's going on with those metadata pairs, because it was scattered all over the place and you couldn't understand what's going on. And we spent maybe 2 weeks on fixing it and made a table like that. It's just a size with the product ID, added a link to basket item, and it actually helped us. So we've spent 10 months since January up to November fixing all this stuff like that, fixing the reservation system because it was similar, fixing ordering system because it was similar. So the November 2015 was a huge commercial success. And well, there were a mistake made, and we had 3 hours of downtime. And yeah, I mean, how do we fix that? I mean, we've spent almost a year, and it still is, I mean, even without that mistake, we had a problem where every time we had a peak of users, like new campaigns came out, the users came to us, and we had how do you call it, deadlock in a database, and nothing replied for 5 seconds. And deadlock was somewhere in the code which added the product to basket, but where? I actually never found out. It was just too hard, there were too many queries. And the Postgres never told me anything. I mean, it wasn't really helping us. So, I mean, nobody actually knows why stuff was made like that. There were nobody in the team who knew why the metadata pairs existed at all, like, and other stuff. And the actual system, it was written in Django, and it was started in 2006. And I mean, it was like 9 years of development, so there were a lot of code in save methods, in signals. So you just call some method, and it goes all around the place and calls various stuff. There are signals fired, some handlers called, and you actually never know what's going on. There were a method called getActiveBasket, and it called another method named underscore getActiveBasket, and called another method. And in the end, there were like chain of 4 or 5 methods, and in the end, it actually created a new basket. So yeah, it was really hard. And as I said, we once fixed a bit how the products are displayed, and nobody could actually order them after that, because the ordering system used presentation layer of products. So it was weird. And it was not performant. So we obviously decided to rewrite. I mean, there are maybe other ways, but just that was our way. We just, decided what do we want to see in the end. And we're just doing bits by bits. We started rewriting in the middle of 2015. And I mean, it was just like a slow thing. We were fixing stuff, like not fixing, but trying to make all the APIs we need to put a first page. We decided that we want to replace one of our pages, probably main one, like index page, with a new system. But there is a lot of stuff you need to do to like replace a single page, because there are pop-ups, there is registration and stuff like that. So you have to do a lot of stuff. And we decided to rewrite it in Clojure, obviously, because there is a main reason. I just like it. And do you actually need more reasons, right? I mean, if you like if you like the platform, nobody is going to. I mean, there are actual reasons, right? The technical ones, which I came up with so I can support the first one. I mean, there were actually 2 reasons why we rewrote it in Clojure. First one was that I really like the language I mean, it's not like I'm liking it in vacuum, right? I'm liking it because it's expressive, because it's fast, because I was writing in Python, so switching to JVM made things magically much faster. And it's practical, and immutable data structures working great. But that's why I like it. And the second reason is that if you asked someone to refactor something in Python, he would just go to the original implementation, read what the original implementation does, and write the code from scratch, but it would be looking quite similar to what he read. Like, he fixed obvious problems, but the whole structure would stay in place. And with Clojure, there is no way he can do that. I mean, you just can't call method on something, right? I mean, it doesn't work like that. So they had to think, how do you rewrite stuff? And we decided to do a single-page application. I mean, it's a controversial decision was at the time for us, because we're in an e-commerce shop, and that's not an application. That's more like a site, like closer to Wikipedia than to Gmail, right? But if you're doing single-page applications, the first thing is that it's much easier. I was just tired of jQuery. I mean, we had a lot of jQuery plugins which were showing pop-ups and moving things around. And at some point, somebody said, like, can we display part of that page here on when you like press a button and then you make an API for that, which returns part of HTML rendered on server. So it's just painful. And another one is that every reload on a traditional site brings much more data than you need in a single-page application, because your header is already drawn, your footer is already drawn. You just don't need to fetch all those surrounding data. You just need to make a single request to a product. And it actually forces you to create API which works, which can be used by mobile phones. And that was a pain for us, because API for mobile applications was just another piece of Django code, and it was like not really maintained, because everybody was looking at desktop side, so mobile applications suffered a bit. Of course, there is a slower initial load, and we're still struggling with that one. I mean, we're constantly improving it bit by bit, but you need server-side rendering for sure, and if you want to see that on mobile phones. So I've spent some time playing with server-side rendering. And the first thing I tried is Nashorn. You probably know that's a JavaScript engine inside of JVM. And it worked really well with the small examples. But when I loaded a real application, it was taken, I mean, it just destroyed my laptop. It was burning as hell. And I've spent 15 seconds waiting for a first mistake, just fixed that, and they waited for 15 seconds for a second mistake, and I just imagine how my front-end developers are going to wait for 15 seconds until they find their problems. And given that they were writing JavaScript and CSS before, so they're used to fast turnarounds. They're not the guys who waited for C++ compilation times. So we tried out Node.js. We just did an HTTP server, Node.js, and the API forwarded the original request to Node.js, and Node.js just returned a string of rendered page. And the idea was that you start a single JVM on the server, and then it manages pool of Node.js processes, because the application uses global ATOM for data management in memory, because that's in a browser usually, right? Nobody cares about global variables in a browser. And we thought, I mean, it wasn't that fast for us, so we thought we will just disable server-side rendering for desktops, and we will render for phones and Google bot. And so that was how it looked. The request comes in. You use some function which will render your, page, and write it back to somebody who requested that. And the render method looked function looked like that. So it called to React to render all the components, and the rendering components fired off XHR requests. And when the XHR requests all finished, we just waited for them to finish. We rendered it again so that it will be filled with data, not just like empty stuff, right? And how was it? The first thing that you serialize all the JSON responses and then deserialize them in Node application. Then you have to manage a pool of Node.js processes, and they leak memory and die sometimes. And you render everything twice, so the single render of a single page took around 350 milliseconds, 400 milliseconds. I mean, that's just painful. So we were not really happy. But then I came here in Philadelphia a year and a half ago on ClojureConf 2015. And there was a guy making a talk about optimizing ClojureScript, and it turned out to be about different things. And the thing is, for the last 2 years, Clojure got a case when you can write a single file, CLJC, which is executed both on the server and on the client, like the same code. And our front end was in ClojureScript, so we just moved all the front end to CLJC. And so how does it look? I'll just describe how stuff works right now. We have this component which is just div and span in a div, right? It's simple enough so that you can understand if you don't know syntax. And it renders to, well, it actually compiles to JavaScript like that. It just creates class with the render function which returns some HTML. And on the server side, that component actually compiles to the function, which will return your data structure as it is. And then there is another function which just compiles all the data structure to an HTML. So you write once, you write component once, and it's rendered on the front end and on the server with no problems. And yeah, so it's multi-threaded, and global item is not a problem because there is a binding in Clojure, and you can say this item is not really global, it's just local for this thread. And you can directly call an API with no serialization, so the server rendering is really fast. And I mean, our baseline for a single page, for a complex single page is around 70 milliseconds right now. So it works pretty well. And yeah, I didn't make a real transition here. So that's the other part which I really like. So we had this problem with the schema being really weird, and we actually had a Postgres, Cassandra, React, Redis, Memcached, and maybe I forgot something, but the previous team really liked databases. So we've got quite a bit of them. And bit by bit, we actually moved everything to Postgres, and so we removed already React. There is no React, no Redis, and Cassandra is going away this month. And the only thing which really not worked well is Django RM, which was bad. And we're writing queries like that right now. And it's just a normal map which you can compose, however you want, which is actually the main proposal of ORMs is that composition works much better than with the strings, right? And there is no problems here. So what's the result of that? Well, we had like almost 100,000 lines, and those are replaced by that part and that part. So we have 6,000 lines in our API and 5,000 lines in event streaming processor, which just processes orders and stuff like that. And we have quite a bit of front end, but that's like more than half of that is the same as templates in HTML. So it's hard to compare, but I mean, it's much smaller than it was. And it's much, I mean, our team is 4 backend developers. So we are dealing with all this stuff. We've sent, so to put this in perspective, we've sent, last March, we've sent 4,500,000 orders, which means around, how many? 15,000 orders per day. And it's only 4 people doing that, so it's pretty efficient. And the median API response time for us is 18 milliseconds. I'm talking median, not 99 percentile, because we have some API methods which are skewing the image, and they're not really for the users, like internal stuff, and I was too lazy to calculate all this stuff. Anyway, so we had 18 servers with Python, and it died, and it was dead for 3 hours until we managed to get it back online. And right now we had 8 servers with Clojure this Black Friday, and currently we have around 1,000 RPS right now in April, and it could be survived by a single server. So it's pretty okay, and we know how to optimize further. It's pretty easy, and it took almost a year to rewrite all this stuff. We were doing a lot of other stuff with the old system as well, but still, I mean, it wasn't really fast. It was just the whole 2016 was spent on that, and the Black Friday we had no problems, and it actually. I mean, this part is just to put that in perspective, the peak load. It was like 5 times bigger than in summer. So I'm not sure about 4,000 RPS. I heard, well, David Hanson once wrote in Twitter that Basecamp is now high load site because it's doing 3,000 RPS. So I guess I'm high load as well now. But then it worked okay. Thank you for listening. I mean, if you have any questions, I'm happy to hear them.
So you run a team of 4, right?
Well, it's actually bigger, right? We have 3 iOS developers, 2 Android developers. There are 3 front-end developers. But the team which is doing the back-end is just 4 guys.
So okay, so for the back-end guys, what was their experience before? Or did they have Clojure experience already? Or is this new for them?
No, well, they were all Python developers. I just sold the Clojure. I mean, it wasn't hard. I mean, it's an exciting language, and it's something new to do. And the transition wasn't that hard. I mean, they spent everybody of them. I mean, we hired the guy half a year ago who did Clojure before that. He was working on an Urban Dictionary, and they're apparently in Clojure partly. But then all others just spent some time on forclojure.com fixing, I mean, doing tasks, and that's it. So it wasn't the problem.
Okay.
Are these servers, the Python and the Clojure, they're on hardware, or are they VMs?
No, that's all hardware. We have a lot of hardware right now.
Okay. And the other question is, how do you do state management, like connection pooling, stuff like that?
Connection pooling to a database?
Yeah.
I use C3PO, or how do you call that? Just the library. I mean, it just works. We're building an Uber jar, and then just deploying that on the server.
So just lining in Uber jar?
Yeah, so just a simple Uber jar. I mean, it works. We actually switch into containers and some, I don't know, Rancher, Kubernetes, something like that. But it didn't happen yet, because Uber jar takes around 5 minutes to build, and I'm too impatient to wait until that deploys. So yeah, to production. So we're switching to Docker because it will be, I mean, built faster, hopefully.
Sorry, one last question. Didn't mean to monopolize the questions, but so like in terms of Clojure and immutability, how do you feel that if it did at all, it simplified your code base?
Well, it did. The nicest part of all that is that in Python you have this imperative code which is doing stuff, like you're doing some stuff, and if this condition is truthy, then just call some method and it changes something in the database. And in Clojure, you have to build pipelines. So you gather some data, and then you pass it through the whole pipeline, which checks some stuff, adds like more data, and then writes all the database. And that is much easier to test, much easier to isolate problems, and just makes code much simpler. The biggest part of our code base, which is like the most complex part, is the checkout. And I mean, it takes half a day for a guy to get to speed up to fix something in checkout. I mean, so it's okay. I mean, it takes time, but it's a complex part. And in old Django, we were like, yeah, nobody really knows what's happening there, so sorry, we will not fix that problem. We will just like patch it up, and that's it. And it was always like that, right? It was, I mean, the whole Python code was just patches around on top of patches and on top of patches, and you just did some. And so what you're doing before the actual code starts, you add another if and check if the conditions are right for the problem, and then do something that it will never happen later on. And yeah, so we went from that to the actual normal code. We actually used ClojureScript to like describe types which are going through all this process, and use generative testing to test that. And so it was fun.
I'm curious about the size of your JVMs on this, the Clojure JVMs, heap size, and if you know.
16 gigabytes, maybe.
I'm sorry, how much? 16
gigabytes. Yeah, I'm not exactly sure, because I mean, we had some memory leaks, and during memory leaks, I remember our heap dumps are usually around 20 gigabytes.
Okay.
So yeah, and when there are no memory leaks, I'm not sure how big they are, because I don't really care. I have 3 guys which are working with this in production, so they probably know, but I do not. I mean, somebody bought a lot of hardware a few years ago, so I have a lot of servers to run on this on. So I don't really know.
Quick question, what is the maintainability story of the Clojure code? Do you guys find it readable and easy to kind of go in and make adjustments, or is it a little bit more difficult?
You see that the answer to the question will be subjective, but yeah, I do find it easy. I mean, we were not writing any macros. We were not doing any weird stuff. It's just more or less simple code. The part where we have that event stream processor, this one, it's in Onyx, and that one is a bit harder because Onyx, it's a new shiny thingy, and that's always harder. But then on the regular API, it's just really simple, because the whole API looks like that. Get an ID of campaign, go for the campaign, retrieve campaign, return it. It's a bit more complex, but a little bit. So yeah, it's not a problem right now. We have a guy who is working mainly with Python right now, because he's just going and fixing up old stuff, so that we can migrate that. And he's coming to Clojure maybe once a month, and there is no problem. So yeah.
How much would you say, in terms of feature completeness, is the new Clojure version with the old Python version? Are you 100% feature complete, 90%?
No, not really. I mean, there were a lot of features which were never used because nobody knew about them. We actually discovered quite a bit of stuff which nobody in company knew about. I mean, the site started as an Australian one, and then was in Turkey, and then somebody took the code and it was running in Ukraine. So, we actually removed around 10,000 lines of code which were rendering pages with text in Turkish language, and I'm not sure what was that, but so yeah. It's not 100% the same. I mean, it's totally different. That's why it's hard to compare. It's obviously, if you're not running in the problem where you rewrite everything to be 100% sure, you can just write better code because you know what you need. I mean, we knew use cases, so it was easier. So yeah, I mean, part of that is that. Okay, thank you.